All right, so new topic, new vocabulary word, something you've probably seen before. We're talking about torque. Now, torque starts with a T, but unfortunately, so do several other things. Time, temperature, torque, tension. We have lots of T words. For that reason, I guess to add variety and make it easier to tell certain things apart, torque uses the Greek letter tau, T-A-U, which is sort of like a fancy small Greek letter T, which, that's fine, I guess. I didn't get to pick it. We're stuck with it. It's not that bad. But the definition torque comes from the length of your lever arm. So sometimes this is L, sometimes it's R. R helps people to remember that it's going to rotate around in a circle. So, R for radius, R for rotate, again, could be a memory trick. Multiplied by whatever force is involved. And then if you happen to have an angle, you multiply by sine of the angle. If you're not given an angle, then what we do is we assume that the force is perpendicular. So upside down, capital T for perpendicular symbol. And then sine of 90 degrees is 1. And then it just sort of gets absorbed into the rest of it. So we're just looking at R times F. You do have to be careful here because we are specifically looking at force. So notice in the units here, newtons and meters. So I have the meters, I don't have newtons. But this ought to be relatively easy to fix by now. We've seen a bunch of times. Take mass times acceleration due to gravity, and we can turn this into weight. So there's our newtons. From here, because there is no angle and no additional work, we're not balancing or solving anything, we just get to plug right in. So 1.92 meters for the radius, basically the leverage we've got, and then multiplied by the force there. So the 50 kilogram kid makes almost 500 newtons of force pushing down on the seesaw. The order of the units is important. In most cases, most questions, you're not going to have to worry about that, but on this one, you really do. So unfortunately, if you put the little m for meters in front of something, it looks like milli, like a small portion of something. So we do specifically want newtons and then meters in that order because if you turn it around, it looks like millinewtons. All right, then now to multiply these together, just run them through a calculator, 940.80.